We'll now continue our discussion of section 1.4, the complex number system. We begin with a definition for a complex conjugate. Given any complex number a plus bi, the complex number a minus bi is called its complex conjugate. What this is saying is that if you have a complex number, for example 5 plus 7i, that the conjugate would be changing the middle sign. So the conjugate would be 5 minus 7i. Or if you had negative 3 minus 5i, the conjugate would be, again, changing the middle sign only. So you would have negative 3 plus 5i as the conjugate. Our problem asks us to simplify the following expressions. Part A asks us to simplify 2 plus 3i divided by 3 minus I. The problem is that when we have a complex number as part of a fraction, the complex number is not considered to be in simplified form if there is an I in the denominator. And so in an effort to get rid of the I in the denominator and simplify the complex number, we will employ a technique where we will multiply both the top and the bottom by the conjugate of the denominator. So if my denominator is 3 minus I, the conjugate would be 3 plus I. And what we're going to do is multiply the same quantity on the top as we do on the bottom. So in other words, we'll multiply the top and the bottom by 3 plus I. Now we're going to employ the FOIL method in order to do these multiplications. So on the top, first times first is going to be 2 times 3, which is going to give us 6. Outside is going to give us 2i. Inside will give us 9i. And the last two will give us 3i squared. We're going to do the same thing in the denominator using the FOIL method. First times first would be 3 times 3, which is 9. Outside, 3 times I would be 3i. Inside would be negative 3i. And last would be a negative I times a positive I, so a negative I squared. Now let's look at simplifying this. On the top, we're going to combine our middle terms. So 6 plus the 2 and the 9 make 11i. And we're going to go ahead and in place of this I squared, remember that we can put in a negative 1. In the denominator, we have 9. The middle terms cancel each other out. And again, in place of this I squared, we're going to put a negative 1. So we have 9 minus negative 1. So the numerator, when we simplify, becomes 6 plus 11i minus 3. And the denominator, 9 plus 1, which gives me 3 plus 11i over 10. And we can leave the answer in that format, or you can go ahead and break up your fraction and write it 3 over 10 plus 11 over 10 times I. And either way is acceptable. So let's look at part B. Part B has 4 minus 3i raised to the negative 1 power. And we know that if we have a negative 1 power, that we can cause that power to become positive if we move it down in the denominator of a fraction. So this 4 minus 3i raised to the negative 1 is equivalent to 1 over 4 minus 3i. And now it becomes to the positive 1. And so as we look at that, we know that it's not quite simplified because we have the I in the denominator, which we're not allowed to have. And so we will multiply top and bottom by the conjugate of the bottom. So we're going to be multiplying by 4 plus 3i on the top and on the bottom. Now the top is easy because it's going to be 4 plus 3i times 1. So the top is not going to change. The denominator we're going to use our FOIL method for. So first times first, 4 times 4 is 16. Outside will be 12i. Inside will be negative 12i. And the last will be minus 9i squared. So we have 4 plus 3i in the numerator. The middle terms are going to cancel out on the denominator, so it's going to be left with 16 minus 9i squared. And in place of that I squared, we're going to put a negative 1. So we have 4 plus 3i over 16 plus 9. So we have 4 plus 3i over 25. And again, we can leave it like that. Or we can break it up into two fractions, 4 over 25 plus 3 over 25 times I. And either way is acceptable. Part C of our problem, we have 1 divided by I. So what is the conjugate of I? We might want to consider this problem as being 1 over 0 plus I. And if we look at that, 0 plus I, that's the same thing as this I that we started with. We can now see that the conjugate would be 0 minus I. All right, now I'm going to go ahead and rewrite without those zeros just because it'll make it easier to work with. So I'm going to go back to 1 over I and multiplying by negative I over negative I. But putting those zeros in just helps me see what the complex number originally looked like and also helps me to see what the conjugate looks like. So now as we multiply on the top, 1 times negative I is going to be negative I. And on the bottom, we have 1 times negative I, or I'm sorry, I times negative I, which would be negative I squared. So we have negative I over negative, and we'll put a negative 1 in for that I squared. So negative I over positive 1. And so our final answer will be negative I. All right, so let's look at two other examples. These examples, the first one is 2 minus the square root of negative 3, and that quantity is squared. So let's look at what that's going to be as we multiply it out. We are going to write that down twice so that we can see the terms more clearly. So I'm going to write down 2 minus the square root of negative 3 times 2 minus the square root of negative 3. And then we're going to FOIL that out. And so let's do this. First times first. 2 times 2 is going to give me 4. Now I want to be real careful here. On the outside, I'm going to have a negative 2 on the square root of negative 3. On the inside, I'm going to have a negative 2 on the square root of negative 3. And the last ones, we're going to have a negative times a negative will be a positive. The square root times the square root, remember that those kind of, let's see, let's just write it this way to begin with. So we've got the square root of negative 3 times itself. So let's do that, and that will maybe make it a little bit easier to work with. All right, so let's look at simplifying this. So I have 4. These middle terms are going to combine. I have 2 of these square roots and 2 of these square roots. So that's going to make 4 of them. So minus 4 on the square root of negative 3. Now, this last term, when we take the square root and we square it, remember that those kind of cancel each other out, and that's just going to leave us what's underneath. So that leaves us with a negative 3. And so when we combine our like terms, we have a 4 and a minus 3. That's going to give me a 1. And then I have a 4i, or I'm sorry, a 4 on the square root of negative 3. All right, let me come up here a little bit so I've got a little more room to work. Now, I can't do much with the square root of negative 3, but I can rewrite that square root of negative 3 as a negative 1 times a positive 3. And then remember that that square root of negative 1 becomes an I. And so my final answer is going to look like 1 minus 4i on the square root of 3. All right, and then our part B example, we want to simplify this. Now, we may want to go ahead and do the simplification for the square root of 4 because that's pretty easy. We know the square root of 4 is 2, so why not, let's go ahead and just say that that's equal to 2. And what about the square root of negative 4? We know that that is the square root of negative 1 times positive 4. So that's the square root of negative 1 and the square root of 4, breaking it up. And so the square root of negative 1 is I, and the square root of 4 is 2. So we have 2 over 2i, and then we can see that those 2's will cancel, leaving me 1 over I, which is great, except that it is not simplified because we are not allowed to have an I in the denominator. Now, we've actually already worked this problem out. I'm going to flip back 1 over I. We've already worked this out, and we see that it's equal to negative I. So we could just write that down, but we'll talk right back through it one more time. Remember that what we decided to do was instead of having an I, we're going to multiply by the conjugate, which was a negative I. So we're going to come back over here and multiply top and bottom by negative I. So we're going to have negative I on the top. We're going to have negative I squared on the bottom. The negative stays out in the front. The I squared becomes a negative 1. So we have negative I over 1, which is just going to equal negative I.